the ways we can use to measure a mass is using the principle of the lever discovered by or explained by Archimedes and use it in the so-called unequal armed balances. In this case, we have here a typical balance of a laboratory, and we will measure this mass, putting it on this part of the balance, which has this arm, and this other arm can vary, because if we move the mass to a certain point, we will see that the equilibrium can be reached. Yes? So, the important fact is that the equilibrium depends on the measure of both arms, and so we can measure a mass using a distance. This principle of using distances or lengths to measure masses is the basis of the well-known Roman balance or stelyard, which uses a fixed fulcrum and a moving mass to compare and find the value of an unknown mass. In this case, we will show how it works. We will try to weigh this mass. We see that the fulcrum is the point where it is hanging, and we must move the mass until it reaches the equilibrium, approximately. Yes. So we can measure this distance to know the value. We can measure this distance to know the value of the mass that is being hanged. Another type of balance has been developed also in ancient times and is known as Bismarck type balance. It is much easier than the other one because it only involves a stick and the mass on its end. This is one of a lot of examples that could be used. The equilibrium point is here, but if we put a mass on the other end, this mass displaces, pulls the equilibrium point, so that I must put it on this part to reach the equilibrium. We have seen that this new mass has moved the fulcrum to this new equilibrium point, and from the distance we have moved, we can see the value of the mass that we are measuring. We can use this Bismarck type of balances to measure a certain mass. If I put a mass on one of its parts, first of all, we will see that the equilibrium is at the center. The fulcrum stays at the center of the balance. If we now put a mass on one of its ends, the equilibrium is being displaced, so that now the equilibrium point has moved from the center, because it is inclined, to the mass that it is that we are weighing, so that knowing both masses and the distance of the fulcrum, which has been displaced from the center to the mass, we can know the value of this mass. This idea can be used with this kind of artifact, in which the fulcrum is this ball and it lies in the middle, as you can see. But now, if I make pressure on this part like a certain mass, then the scale gets inclined and the fulcrum is displaced to the mass, to the additional mass. And there would be a limit when the scale reaches its limit, that is when the mass is so great that the fulcrum lies over it.